Hello again. So today we will be discussing the topic of the motion of projectile in our dynamics book, section 6 or chapter 12, section 6 in our book starts at page 41. Now, motion of projectile. What is a projectile? Projectile is something that you throw in the air, for example. Assume you're throwing a rock, for example, you're throwing a ball. You might be shooting, so it could be a bullet or whatever. So this rock, for example, is traveling this path. It's a curved line. It's a curved-like path. Now, your rock at the beginning, it starts at some initial velocity. This is v node. This is v node. Starts at some initial velocity v node. Now, you can see that you can take some reference point, for example, this reference point to start with, or this reference point. I mean, it's up to you at the end. So it's flying at some initial velocity v node. V node, as you can see, we could actually break it down into two components, v node in the x direction and v node in the y direction. Now, this rock will travel this path, and the only force acting on this rock is basically the acceleration due to gravity, which is g, acceleration due to gravity. And you can see here that it's acting on the rock downwards. So g should have a negative value, or a should have a negative minus, so this is negative 9.81 approximately meters per second squared. Now, as you might have noticed, there's no force acting on this rock in the x direction. So now we can immediately conclude that the acceleration in the x direction is 0. So now what? What do we have? We have this acceleration in the y direction equals minus 9.81, and this is a constant. Also, the acceleration in the x direction is constant because it's equal to 0 meters per second square. So now we have constant acceleration situation. It's true that we have this motion, which is like curve-like motion. So we used to solve these problems using the not the rectilinear, but the curvilinear motion. But now, at each point here, you can break it down into x and y components, which means that we have straight line motions both in the x direction and in the y direction. So we can make use of the rectilinear kinematics, right? Rectilinear kinematics. Rectilinear kinematics, meaning that we have, okay. Meaning that we have a motion in a straight line. It's a straight line motion. So we can make use of our equations that we came up with in section 2 of chapter 12. Here we were saying that we have a constant acceleration situation. So there we could come up with these three equations, you remember probably. V equals V naught plus ACT, S equals S naught plus V naught T plus half ACT squared, and V squared, and this is final, right? When we don't write anything here, so this is final. This is final position. This is final velocity squared equals the initial velocity squared plus 2AC multiplied by S final minus S initial. Okay, so what do we have and what do we know? We know that A in the y direction is minus 9.81 meters per second square. In the x direction, AX equals 0 meters per second square. Okay, so now let's apply these to what we know, to the equations that we know already. So as I said, we could break down our information into x and y information, right? X and y components. So what if we start working with the horizontal directions, horizontal direction. so in the horizontal direction. Here, in the horizontal direction, the only thing that we know is AX equals 0 meters per second squared. And instead of S, we could write X, right? So this is the X distance. So X instead of S, or X node instead of S node. Apply these into our equations. So here into the first equation, and then also instead of V, we could write Vx. This is V. And V node now is, and this is Vx final. So this is V node. No, so we said that Vx is V, and this is V node X. So this is V node in the X is V node. Substitute this information into these equations. So the first one, V, the first one becomes V is Vx equals V node in the X direction plus Ax. So Ax now has a value of 0. So that's it. So plus 0. This is 1. 2. S, we said we could substitute S by X. So this is X. The final X position equals the initial X position. I mean, you don't have to write X anyways, it's X. So, plus V node now is V node X multiplied by the time plus 0 because AC is 0. So X equals X node plus V node in the X direction multiplied by the time. And the third equation is, now this is Vx squared, V node Vx squared, V node X squared plus 0. So we will come up with the first equation. It's exactly the first equation again. So V node X, right? Just you need to take the square root for both sides. These are the equations that we can use. Basically, we have only two equations, the first one and the second one. We know that the final velocity in the x direction equals the initial velocity in the x direction. Also, we know that the final position in x equals the initial position in the x plus the initial velocity in the x multiplied by the time. Okay, now let's work with the vertical. Let's just change the color. Let's just say green. So let's work with the vertical direction. Now, in the vertical direction, we have A in the y direction equals G, right? And this is minus 9.81 anyways. But you remember this has a negative value because it's acting downwards. What else do we know? Same information here. Now y is the final position. Y node is the initial position. We have V in the y equals V, which is the final velocity in the y direction, and this is the initial velocity in the y direction. Substitute that for V node. So we go to our equations here and we start applying these things. So in the first equation we get Vy equals V node in the y direction. Now plus minus G, so this is minus G multiplied by T. And now guys, please be attentive that whenever we start solving our problems, you have a value of G of 9.81. Don't substituted as minus 9.81 again, because we already took the negative into consideration. So we took the negative sign into consideration, so do not do it again. Do not do it twice. Just put 9.81 as positive value here in this equation. So this is our first equation. The second equation is, this is y. Y equals y naught plus the initial velocity in the y direction multiplied by the time minus, right? So this is minus half gt squared. This is the second equation. And the third equation, similarly, the final velocity squared in the y direction equals the initial velocity squared in the y direction minus 2g multiplied by the final position in the y direction minus the initial position in the y direction. So these are our three equations. This is 1, this is 2, and this is 3. Now, something that you need to notice here is in equation 2, equation 2. If you move x to this side, you get delta x minus x naught equals the initial velocity in the x direction multiplied by time. This difference, delta x, is called as r, and r is the range, which is the difference between the initial and final positions in the x direction. We'll see that in some questions later. So now, whenever you have a problem and you need to solve, remember you have two equations. This is the first one, and this is the second one. Basically, now you could actually, this is very simple to work with. Now look at this equation, guys. We have final position in x, initial position in x, initial velocity in the x direction, and time. Now whenever you have a problem, you start first by looking at your equations. Okay, we go here. Do we have enough information to solve for whatever we have? So then we decide whether or not to use this equation. So if v naught x is not asked, you're not required to solve for v naught x or x naught, then you don't use this equation. You go now into these equations and you start looking, what kind of information do we have, and what things should we use, what equations should we use in order to solve our problem. So you start from here and you go here. Just go in order. 1, 2, 3, 4, and determine which equations you need to solve your problem. Very easy topic, but you have to be consistent and you have to be accurate. Later we will see how to solve several examples and problems. Easy stuff, so I'll be explaining more in the upcoming videos. Alright, thank you.